Hello everyone, I am Prabhakar Singh, a senior software engineer at Meta. Today, we are going to talk about something that's both a technical challenge and a real-world business necessity. Building real-time, AI-powered fraud prevention systems for gig platforms in Rust. And here's the exciting part. This is not just a theory. I will share some systems that are already in production, blocking millions in frauds every month, processing tens of thousands of transactions per hour, and doing it within millisecond decision times. So let's deep dive into it. So here is our roadmap for today. We'll start with fraud challenge in the gig economy. What makes it so much harder than fraud in traditional banking or e-commerce? Then we'll see why Rust, specifically Rust, is a perfect fit for solving it. I'll walk you through a multi-layer architecture that's battle tested. We'll dive deep into real-world results from food delivery and ride-sharing platforms. And finally, I'll share some emerging applications where Rust can push the fraud prevention even further. By the end, I hope you'll see why the next generation of fraud prevention could be written in Rust. So let's look into what's the gig economy fraud challenge. Fraud prevention in gig platforms is a game of milliseconds. Imagine you're ordering food on DoorDash or booking a ride on Uber. If our system takes even 150 milliseconds longer than expected to approve your transaction, you might abandon the order, or the driver assignment might time out. That's a revenue lost instantly. On top of that, gig economy is hyper-distributed, meaning workers and customers are scattered across cities, countries, even continents, meaning fraud patterns are geographically different and constantly evolving. Payments are instant. Once the money is sent to a driver or a courier, it's gone. There is no hold period to investigate suspicious activity like in banking. And the throughput requirements? We're talking about AI models analyzing thousands of transactions every minute without even choking. Where's the problem? The Python, Java, Node.js, they can work. These are popular frameworks. But under these constraints, they often force painful trade-offs between speed and accuracy. We need both. And that's where the Rust changes the game. Let's look at the common fraud patterns we have seen. So fraudsters are very creative and relentless. Let's look at a few common attack patterns that we have seen in gig platforms. So one commonly is known as account takeover, where attackers buy leaked credentials and brute force their way into legitimate systems or accounts. Synthetic identity is another type. Think of it as a Frankenstein accounts stitched together from real and fake details. Another one is worker-customer collusion. A driver and a customer work together to fake trips or deliveries. Another one called GPS spoofing or geo spoofing, where they fake their location to get better jobs or to trick the payout system. Finally, another type is payment method fraud, where stolen credit cards are used for instant payout. And here is the scary part. Fraud tactics evolve weekly, sometimes daily. A fraud ring can exploit your platform, make hundreds of fraudulent transactions, and vanish before your old detection rules even notice something is wrong. That's why our system have to be fast, adaptive, and accurate all at once. So why Rust for fraud prevention? So there are three big reasons for that. First, memory safety without garbage collection. Fraud prevention systems are security critical. A buffer overflow or use after free bug is not just a crash. It could be an exploit. Rust eliminates those classes of bugs at compile time without runtime GC pauses. Second, C++ level performance. As we know, C++ is a very popular programming language. So Rust has zero cost abstraction. It has multiple LLM optimization. You can hit near C+ speed while writing safer and more expressive code. Third, fearless concurrence. The ownership And the borrowing model prevents data races by design. That means we can confidently run fraud checks on many concurrent transactions without corrupting the shared estate. In short, Rust gives us a speed, safety, and scalability, the trifecta of fraud prevention. Let's look at the performance results. In production benchmarks from a major food delivery company, Rust reached 93% of C plus raw performance. It was 6.2 times faster than Java and 12.4 times faster than Python with TensorFlow. What is the P99 latency? Under 35 milliseconds consistently. And these are not just a synthetic test. Even CPU utilization was dropped by 90% compared to Python. These are real world numbers from a live fraud prevention pipeline. And why? And when you multiply that efficiency across thousands of requests per second, the cost savings are huge. Let's look at a multi-layered Rust architecture. So our Rust-based architecture uses 5 layers mainly. 1, real-time stream processing, where Tokyo ingests transaction streams and processes them asynchronously, cutting latency dramatically. Second, rule-based detection. Simple if-else rules and on pattern matching for known fraud signals are sufficient. Think if same card used in 3 countries in 1 hour, flag. Third, statistical anomaly detection. Time series models to spot unusual spikes or dips in user behavior. ML classification. Candle deep learning models used with CUDA acceleration for GPU inference. Graph analysis. Pet graph algorithm to detect suspicious clusters of users working together. Each layer acts as a safety net, catching what others might miss. Let's look at Rust power in innovations. 2 things made a huge difference here. Async stream processing with Tokyo, which lets us handle thousands of events per second with almost no idle time. And the second, zero copy deserialization with Shade, which parses JSON or protobuf straight from bytes without extra memory allocations. On their own, these are nice to haves, but in real-time fraud pipeline, they are the difference between hitting your SLA or missing it by 30 milliseconds and losing money. You can look at some code snippet here that I have attached in this slide that you can use directly in your code to use these frameworks. Let's look at ML inference with Candle. If you have used PyTorch, Candle will feel very familiar. It's a pure Rust ML framework, supports ONNX imports from PyTorch or TensorFlow, and runs on CUDA and Metal for GPU inference. The best part, no Python in production. That means the whole fraud detection pipeline is memory safe from end to end, no language boundaries, no GIL, no extra process overhead. Isn't that amazing? Let's look into graph analysis with pet graph. So as we know, fraud does not always happen in isolation. It's often coordinated. Pet graph lets us map out transaction graphs and run algorithms to find what? 1, connected components. 2, centrality scores. 3, structural similarities over time. One real case, 32 drivers and 18 customers ran a fake order scam for weeks where standard ML models missed it. The graph analysis from PetGraph caught it. Isn't that amazing? I have linked a code snippet here again for your reference. Let's move on. Privacy preserving techniques. We can't fight fraud at the expense of privacy. In Rust, we have implemented fake encryption, computation on encrypted data, learning, which is like training across devices without centralizing sensitive data, differential privacy, which is adding control noise to protect identities, secure enclaves, which is running code in hardware isolated environments. And thanks to Rust performance, these are not just slow, they are production ready. Let's look at the ride sharing case study here. A ride sharing platform was losing around $3.2 million per month to geo spoofing or GPS spoofing and fake identities. We replaced their Python fraud stack with Rust microservices. For example, use Tokyo for async HTTP, custom device fingerprinting in Rust, WASM modules for distributed rules, and used Candle for ML inference. What's the result? 87% less fraud loss, 65% fewer false positive enforcements, and 99.98% uptime of services over 12 months. Isn't that unbelievable? Let's look next at emerging applications. So what's next? So these are the 4 use cases that we can use for Rust, and I think the way Rust can shape the industry. So one is behavioral biometrics, typing, swiping, motion patterns as continuous authentication are possible now with Rust. Explainable AI pipelines, which are under 6 to 12 months of pipeline. I mean, in the roadmap, you can have SAP, Lime in Rust for transparent fraud decision. Advanced fully homomorphic encryption, also known as advanced FHE, which is like 12 to 24 months in the roadmap, which for making a privacy preserving fraud detection practical. And native GPU acceleration, which is around 2+ years in the roadmap, where Rust GPU and Candle can be used for even faster inference. So what are the key takeaways? There are 3 main key takeaways from this. So one, performance matters. So Rust gives us C+ level speed and developer productivity. Second, safety is non-negotiable. Memory safety and race-free concurrency reduces risks. And third, the ecosystem is ready. Tokyo, Candle, Petgraph are production-proven ready today. So thank you. Let's build safer gig platforms together. Thank you for listening.